Mr. Eddie Fong, Chairman of MPMA PLASTECH MONTH 2021, Secretary General of MPMA, distinguished guests, ladies and gentlemen, good afternoon and salam sejahtera. Welcome to our second webinar for Malaysia MPMA's PLASTECH Month 2021 with the topic of plastics for the end products. Please, this is the normal webinar etiquette, which I will highlight. If you have any questions, please post it onto our chat box as you can see below. We will pick it up, and our moderator, Dr. Fahmi, will ask the questions to the appropriate speakers. The MPMA Month 2021 with the theme Staying Relevant, the Power of Technology is brought to you by MPMA with the generous sponsors of sponsors from the Malaysian plastic industry. Please allow me to thank each and every one of them. Our exclusive platinum sponsor, Monitor ERP. The list of our gold sponsors are PT Bob's Jakarta, Milliken Asia Private Limited, NGR Malaysia Sdn Berhad, Petronas Chemical Group Berhad, Reifenhauser Blown Film GmbH, and Windmuller Hosher Asia Pacific Limited. Our silver sponsors are Artbert Sdn Berhad, Normechanica SPA, and Cispro Software Malaysia Sdn Berhad. Our bronze sponsors are Autodesk Malaysia, Ben Mayer Specialist Malaysia, Baruch Private Limited, Husky Injection Molding System Malaysia Sdn Berhad, Rickerman Malaysia Sdn Berhad, Sigma Soft Sdn Berhad, and Torre Plastic Malaysia Sdn Berhad. Our other sponsors are Krightbert TPE Technology Malaysia Sdn Berhad. Thank you once again to all sponsors for making the MPMA PLASTECH Month 2021 into a reality. This is our exclusive sponsors video, which we will be playing. Without further ado, it now gives me a great pleasure to invite our moderator for this topic, Dr. Fahmi Asyadi, who is currently a senior lecturer in University Kuala Lumpur. Dr. Fahmi recently obtained his PhD in chemical engineering in polymer from UniKL. He has been lecturing in UniKL since 2002, and Dr. Fahmi is a member of MPMA PLASTECH Month 2021 organizing committee. I'll pass over to you, Dr. Fahmi.
Thank you, Suming. Okay, Assalamualaikum. Good afternoon, everyone. Welcome to MPMA PLASTECH Month 2021 webinar. My name is Fahmi Asyadi Muhammad Yusof. I'm from University Kuala Lumpur. I will be responsible for hosting this presentation today with the theme Plastics for the End Product Application. For this afternoon session, there will be 4 speakers. The first speaker, we have Mr. Amos Tay, Application Development Engineer, Baruch Private Limited, Singapore. Mr. Amos joined the company in 2012, but overall he has spent over 25 years in petrochemical industry. His work involved in QC, R&D, manufacturing, product development, and even safety and compliance management system. Next is Mr. Samuel Yap. Mr. Samuel is a technical manager in Milliken Asia Private Limited, Singapore. He is in charge for Southeast Asia, South Asia, and Oceania for polymer additive business. Before joining Milliken in 2017, this proud Sabahan worked in a few polyolefin manufacturers such as Lotte Titan, ExxonMobil Chemicals, and SABIC. Altogether, he has more than 16 years of experience in polyolefin industries. The third speaker is Mr. Eric Chia, Senior Technical Engineer, Torre Plastic Malaysia Sdn Bhd. Mr. Eric joined this company in 2015. From the job scope, one can tell that he is an ABS resin specialist, okay, involved in development, production, and quality control. And besides, Mr. Eric also experienced in process upscaling, lab to process plant scale. Last but not least, Mr. Nazri Muhammad from Idemitsu Advanced Material Malaysia Sdn Bhd. Mr. Nazri is now a Senior Operation Manager for a new plant, Syndiotech Polystyrene at Idemitsu Pasir Gudang Complex, which is expected to be commercialized next year, Q4 2022. He has 15 years of work experience, specifically in chemical processing plant, project management, and business development. Okay, before we begin, I have a few housekeeping notes. Each presenter today, we have a total of 20 minutes for their presentation. Okay. Okay. If the audience have any question for the presenters, please use the chat features in the Zoom webinar text box. Okay. We will hold the question until the end of the session, and I will read the question out loud for the presenter to answer as time permits. Okay. Now, without further ado, I'm glad to welcome the first speaker, Mr. Amos Tay, who will present polyethylene for large diameter pipes. Mr. Amos Tay.
Good afternoon to all distinguished guests and ladies and gentlemen. I shall be presenting polyethylene for large diameter pipes. Okay. A little bit of Borouge and our commitment to sustainability development. So Borouge is a joint venture between Abu Dhabi National Oil Company in UAE and Borealis of Australia. We are leading a provider of this innovative value creating PE and PP solutions. We have more than 3,000 employees globally, and our corporate HQ is in Singapore with production in Abu Dhabi. We have the largest integrated polyolefin complex with annual capacity of 4.5 million tons, and fourth expansion phase in the petrochemical complex is underway. We have state-of-the-art innovation center in UAE, which involve in product development as well as improvement in our performance of our material. And we have an application center in Shanghai, focusing in the mobility business to support China business in the mobility. And we bring value creation through people as well as innovation. ADNOC strengthening our position as one of the least carbon intensive oil and gas producer. And our target is to reduce the greenhouse gas intensity by 25% by 2030 and extend our carbon capture capacity fivefold by 2030, about 5 million tons per year. So this is approximate to 5 million acres of forest. And we provide everyday plastic solutions in agriculture, as well as packaging for food and daily stuff, healthcare, mobility in external like bumper as well as the internal hosiery, energies in wire and cable insulation, infrastructures in terms of piping and other relevant material. For infrastructure, our business are divided into 3 subsections. Utilities, this is focusing in pressure, water, and gas. construction, focusing in plumbing, types of indoor application, and also soil and wastewater discharge, and water harvesting facilities, as well as geomembrane for landfill and mining application. For industrial, typically it's more of a large diameter relating to a refinery or oil and gas, with this large diameter for seawater intake and outfall. And this is these two are steel pipe coated with polythene for transportation of oil and gas medium. Bondsafe is a family of pipe material that we have. This is for pressure application. We have black as well as colored, and it range from medium density to high density. So today we focus on this P100 thick wall application. With this grade, it is designed for industrial, mining, nuclear application that requires thick wall of large diameter. What is large diameter? We are looking at more than 1200 mm or thickness SDR 7 to or SDR 9. This could amount to more than 95 mm. So it could be a PN 25 or more, or sorry, PN 25 and less. This mostly for industrial, because we are using it for water treatment and supply for mining, water transmission pipelines, and seawater intake and outfall for thermal plant and the cell plant as well as nuclear plant. Because this pipeline is launched into the sea, so the flexibility is required during service. And all these projects are based because you don't build refineries every day. So these are determined by large project requirement, and this demand also determined by local production capability. If there is possible to make locally, it will be a much low cost compared to ship from other country. Maximum wall thickness of PE pipe can be produced depending on combined factors such as machine, production capability, material property, as well as skill of the operators. Let's look at the difference between the standard low sag polyethylene 100 compared to our low sag, extra low sag material. So if you look at this standard P100, when the material exceed the die after extrusion, is still in the viscous mode, and due to the gravity, the material will flow downwards, so causing a sagging at this bottom region, and this will contribute to wasted material and also higher costs due to sagging. You have to spend time to adjust your parameters as well as the tooling just to try to get to the uniform wall thickness across the circumference. With this new grade that we are introducing, ELSH extra low sag material, a more uniform distributed wall thickness can be achieved with ease and no wastage, around saving about 5 to 10%. How come this is possible? Because this material, when it exits the die, it has a higher viscosity compared to the standard P100. So this material will resist flowing downwards due to gravity and able to cool to form this uniform wall thickness. Here is a trial that is done in Middle East, and this size is 1600 mm, SDR of 17. So according to ISO 4427, the wall thickness tolerance will be around 94.8 to 103.7 mm. With the standard P100, after extrusion, you can see the wall thickness at 4 to 7 o'clock is already outside the tolerance prescribed in the ISO 4427, more than 103.7 mm. Under same condition, this ELS material has been extruded And you can see that the wall thickness at 4 to 7 o'clock is less than 103. It does not exceed the maximum tolerance provided in this ISO 4427. Of course, you can see that there are some of them are still outside the range, less than 94.8. But to achieve a 94.8 is easier than to have a high thickness to reduce it to smaller wall thickness. So much for this introduction of this material. Look at this comparison of properties. RCP, this is the rapid crack propagation. This is a property of this pipe when subject to high impact onto the pipe. This pipe will crack. So this material need to withstand this crack propagation and arrest and before it progress to further length. So this one of, and it has the same performance as the standard P100. For SCG is the slow crack growth. So if the pipe has a small cut or a groove, this groove will grow through the pipe wall thickness. But this material, the extra low sag, has this feature of a slow crack growth resistance. That means the crack will grow slower than the standard P100 material. For MRS, both are P100, so the rating is the same, so they can take the same pressure. For the low sag performance, ERSH is significantly improved compared to the P100, standard P100 material. As for processing, people will think that with the new material, having a better feature, should the processing be more difficult. But the test has shown that the processing condition still within the P100 condition, so they are similar processing condition. So you don't have to do extra tooling or extra stress to make this pipe. Here is just a schematic of grades recommendation for the sizes that is required. If we need a 60 to 70 mm thickness, wall thickness of the pipe, actually our standard P100 3490 LS would be suitable. If you have anything that's more than 70 to 90, then I would recommend LSH material to be used. Of course, if you have anything that's more than 95 mm, the best in class would be ERSH. This grade is made of bimodal technology with hexene monomer. The ease of processability, in addition to the resistance of sagging, is through this improvised viscosity MFR that we have seen. There is a less than 0.15 provision given in the ISO 4427. Again, I must stress that the wall thickness capability changes per local production capability. That means if you're locally, your machines able to make this size, as well as the raw material use, coupled with the operator skill, a good large diameter thick wall pipe can be achieved. Here we have to share some success story. This is success stories in Egypt. So the pipe manufacturer is a Gulf manufacturing company. It has a few projects you can see in this list. New capital, you have a port industrial, you have some desal plant, as well as some irrigation waterworks. And the pipe sizes range from 900 mm to 1600 mm. So this and SDR 11 to 17 is about thickness 81, range from 81 to 94 mm around. And what are the challenges is to find a P100 material that allow production of this thick wall pipe in even wall thickness. With this ERSH, they are able to realize the pipe dimension as well as a saving of 5 to 10% in material costs. There are some project photos for your reference. Next is in Myanmar. So it's in the copper mine. And this application for pipe is for acid solvent transmission. As we know that mining, you need a lot of acid to to wash away the material to get whatever you want from the mine. And the pipe is produced by China Oz of size 800 mm SDR 11. So it's about 74 mm. What they require is a corrosion resistance against acid solvent. So P100 is good against this kind of chemical resistance. And if the installation is in mountain, typically mining is in the mountainous area. And also they want the pipe of even wall thickness. So with this ELSH material, all these challenges has been met and delivered the pipe with the size they want, with savings for the converter. The last example is this in Vietnam. Producer is this Thiên Phong Plastic. This is a province in the southeast of Ho Chi Minh City. The purpose is for seawater transportation into prawn farms. So the pipe sizes were 1200 to 1600 mm, SDR 11 to 17. So wall thickness may be about 94 ranging to maybe 109. So what they need is, of course, they need this suitable P100 material that can be made into even wall thickness, as well as corrosion to resistant to corrosion of seawater. And they need large seawater volume to be transported through this harsh condition at installation site, because you have to go through the sand dune under the river and then go to the prawn farm. So this ELSH, a durable pipeline with minimum maintenance cost, is able to support their operation of the prawn farm. All right. So much for all the examples as well as the material introduction. Here I conclude. Development of this material and pipe extrusion technology have driven production of even larger pipes. Currently, they're even large to 3.5 meter. And the success of the large diameter pipes have been proven in industrial application, as you've seen above. And provided operational pressures are not too high, P100 can be cost effective for large diameter water transmission pipe when whole life costings are taken into consideration, including the maintenance of this pipe or leaks to management. So I thank you very much for your attention on my presentation. Thank you.
Thank you, Mr. Amos, for the excellent presentation. It is very obvious that the developments or research in polymer materials and extrusion technologies that lead to this large diameter pipe production. Okay, now we will turn the time over to Mr. Samuel Yap with the topic often overlooked, cycle time reduction by performance additive for sustainable energy saving and increased productivity. Please welcome.
Hello, good afternoon. Selamat datang. My name is Samuel Yap from Milliken Chemicals, and I assume that you guys can hear me and see my screen right now. So thanks, Dr. Fahmi, ladies and gentlemen, thanks for giving us this chance to talk today, right? And I think Dr. Fahmi read out my long topic, but let's unpack that. So before that, a quick word of introduction of who we are. Milliken, we are a global multinational company. We are actually headquarters in the United States, South Carolina. So more than 7,000 employees, more than 65 global locations, and we are actively expanding as well. We are actually a diversified company. So I belong to the chemicals division, and today talking about plastics, especially polypropylene additives. We are part of the chemical division of Milliken, but we have other large divisions as well in terms of flooring, which is the carpets, healthcare, mainly bandages, and a lot of specialty textiles, uniforms, military fabric, flame resistance fabric, and so on. But really a topic on sustainability. So, you know, whether in the polymers business, chemical business, like today, where we are all, and even the rest of the businesses within Milliken, really the whole global direction in the last few years, right, is how can we be more sustainable? And that is the pressure that we as businesses faces daily as well. And this is just some examples on also the other businesses of Milliken on how we improve the sustainability of the business. So for example, in our carpets, or maybe our carpets and also our textiles, our fabrics, right? So some of them are polyester fabrics. So a scheme to recycle PET, plastic water bottles, and convert them into textiles. In the carpets businesses, right, there is a lot more and more because this is where consumers walk barefoot on the carpet sometimes, right? So a lot of focus on non-use of some chemicals, of some banned substances, red list free declaration. This is our flame resistant fabric. So in terms of sustainability, we also put health and safety, and this is a big push where workers will face hazardous conditions, sparks and fire exposure, and so we have flame resistant fabrics for these important jobs as well. Now, just overall in terms of ISO 9000 and obviously the 14,000 and all the environmental and quality certification as well. Back to carpets, so also recycled content. We have global manufacturing of carpets and a lot of efforts to increase the recycled content. Two examples of chemicals, and we will talk about this much more for the rest of the time this afternoon. One is our flagship product, NX8000 Milad, which is a clarifying agent for polypropylene, and we will share how it can enable the molders to save 10 to 15% energy savings. And also our very new Delta Max performance modifiers, both for virgin as well as recycled material polypropylene, and how it can also improve the processing, optimize the processing to gain sustainability benefits. So if we step back again, right, on a macro level, I think this chart is common. This is like the life cycle, especially of plastics and maybe packaging, but basically all plastics, right? It starts from production of the raw plastic pellets, and then the design and the molding of the final parts. This is where we are. We use and we try to reuse as much as possible. And then end of life, it either leaks away or we incinerate it, compost, and obviously we try to increase the recycling. So these are the three main themes of sustainability in terms of the polymer business. How can we increase the recyclability and after use, upcycle and things like that. Number two, how can we reduce the leakage, especially, right? Leakage as in whether to landfill or worse, to the water streams, to the ocean. And number three, how can we be decoupled from the fossil feedstocks? How can we use renewably sourced biomaterial? And these are the three main themes. But the theme of my talk today is really the often overlooked. What about the design and especially the production stage? And my talk will be about injection molding. What about optimizing the injection molding process to use as little energy as possible to be as sustainable as possible? Sure, all of this needs to happen, but we do not forget small parts of the big cycle where we can also make an impact to increase the sustainability benefits. So today we will be talking about three additive solutions from Milliken. Very quickly is our clarifying agent, Milad NX8000. is our high-perform nucleating agent, high-perform HPN, and also, like I mentioned, the very new Delta Max impact modifiers. And let us look into it one by one. NX8000, right? Right now, the most popular, most advanced clarifying agent for polypropylene, a lot of aesthetics improvement, but today we are really talking about how it can enable the optimization for the injection molders to save energy and to reduce the cycle time. So I have a 3-minute video, so please enjoy.
Do you know? How to let PP be made at the source of production that is environmentally friendly, energy saving, and highly efficient is what we are constantly concerned about compared with traditional polypropylene clarifying agent. Having Millad NX8000 clarifying agent in the injection molding process can effectively shorten the molding cycle, reduce injection temperature and energy consumption by up to 10%. High-perform HPN not only has excellent energy-saving effects, but can even shorten the cycle time. Improving production efficiency provides possibility. Thanks to efficient and energy-saving injection molding processing technology, Milliken products have been independently certified by UL and was conferred by the UL Environmental Declaration Verification. Being the most trusted in the world as one of the third-party product safety and standard development institutions, the market fully trusts UL-issued sustainability declaration verification. If we produce 1,000 tons of Millad NX8000 PP injection molding products to replace ordinary plastic products, it is equivalent to saving 3,672 hours of production time, which is approximately $150,000 worth of expenses, a reduction of 4.1 cars' annual fuel consumption, decreasing carbon dioxide emission by 11.8%, which protects 18,210 square meters of forest area, equivalent to 2.5 times the size of a standard football field. Similarly, if you use high-perform HPN to produce thin-walled products, you not only can reduce energy consumption of around 5 to 8% on average. When a single material is used for takeout packaging, it will be more convenient for unified recycling and reusing. If you need more information about UL, please contact a Milliken representative near you. Come and join us, and together we will protect the world and the environment. chemical.milliken.com.
Right. So I hope the video was clear enough, but let me quickly go through the technical fundamentals on how NX8000, the clarifier for polypropylene, enables this productivity increase. So traditional clarifier before NX8000 was introduced to the market, maybe 10, 12 years ago, there was a dependency of haze, which is the optical performance, the transparency, versus the processing temperature or the injection melt temperature. The traditional clarifier have the drawback that they need high temperature to be able to work properly and therefore deliver the optical performance. If you try to reduce the processing temperature, reduce the heating to your extruder, then the parts will turn less and less transparent, and it does not meet the requirement, because the requirement of a clarified random copolymer is for the optical performance. But since we introduced Millad NX8000, it is insensitive, right? The haze, the optical performance is not sensitive to processing temperature. And therefore, whether you process it at a high temperature or a low temperature, it works fully, it functions properly, there is no degradation or there is no negative performance. And so we can translate that. Traditionally, the industry used to have to process clarified random copolymer injection molding at high temperatures. And naturally, if you are molding it with high melt temperature, you would also need high cycle time. The hotter your melt, the more time you need to cool down in your mold before you can eject properly. And we try to symbolize the size of the circle, the size of the bubble as a magnitude of the energy consumption used. So by reducing the temperature, because now we do not have the roadblock, right? We do not have the bottleneck of needing high temperatures for the clarifying agent to work properly. Most of the time, we can also reduce the cycle time, because again, you are injecting a cooler melt. You now need less cooling in the molding before you can eject properly. And therefore, you can reduce both energy needed for heating of your extruder, as well as improve productivity, right? Low cycle time, up to 10 to 15% productivity increase, which means that the energy needed to produce 1 kg or 1 part or 1 ton normalized will be even smaller. So productivity increase, faster outputs, more parts per machine, but also energy savings per part. Not just the overall haze or the overall transparency that you get the benefit from Milan NX8000, you also get less defect and no voids. Because if you try to use the traditional clarifier random copolymer PP, especially you try to reduce the injection temperature, like we say, it gets hazier, less transparent, and there is usually higher risk and probability of defects, such as white streaks, white specks, and especially voids in certain part of the plastics. So voids are like, it's not air bubble trap, but it looks like that, right? And especially now, right, a very close to home application of syringes in this COVID world, vaccination, voids in a syringe body is a very no-no, right? To let the nurses and the doctors have full confidence that they are injecting it properly. You do not want them to mix up really defects in the syringe barrel to really air bubbles trapped in this medicine they are injecting to. So really, not just energy savings, but really a trouble-free, a robust processing window, less defect when using NX8000. So on average, right, we have talked and verified and accredited by Underwriters Laboratory, the ECV, the environmental validation, as per the video. So on average, we are seeing a 10% energy savings reduction based on the concepts in the previous slide. And of course, you can equate that to more or less 10% reduced CO2. Because if you reduce or if you use less electricity, then you need less generation by the power plants, right? And if we convert that CO2 equivalent, for example, let's just use 8,000 tons of polypropylene produced per year, then the 10% of CO2 is equivalent to 74 acres of carbon capture by forests, by trees, or let's say 68 cars per year, the carbon dioxide emission, right? So even by optimizing, if each of the injection model can optimize 10% less energy use while still producing the same number of parts, that's a net win for the whole sustainability globally as well. And so obviously there is a lot of trials in the past years, various different parts, as long as it is containing NX8000, especially for random copolymer, right? Be it like pumps, closures, or containers, or tin wall. So various regions, various types of machines. On average, the 10% reduction in cycle time, 7 to 25% in energy savings, electricity savings, and thus CO2 emissions. And you can put a green label as validated by UL on the parts and the brochures to educate the rest of the consumers and the industry. But don't forget, if you calculate the dollars and cents, if you put your energy costs, your overhead, your labor costs, your depreciation, and you put it all in, 10% reduction in cycle time with the productivity that it brings, can sometimes brings up to an average of $100 per metric ton process of dollars savings, right? And this is pure processing optimization. It's not talking about, you get a cheaper material, but with NX 8000 clarified RCP, optimizing the processing conditions alone, giving you the dollars savings as well. Now we move on to Hyperform. It is very similar in concept. This is mainly more for homopolymer and impact copolymer. Apologies, homopolymer and impact copolymer. And we have again worked with Underwriters Laboratory. So an example here is for thin wall injection molding, where again the HPN, the Hyperform, enables this 5 to 8% energy savings. And this time it is mainly about the core effect of nucleating agent. HPN, Hyperform, nucleating agent. What it means is that when it is injected into the mold, it enables a more efficient nucleation and crystallization of the PP, and therefore it solidifies, it sets quicker and faster in the mold compared to a polypropylene without HPN. And again, all the data suggests on average 5 to 8%. This is what we were talking today in terms of optimizing the processing conditions, but there is a bigger benefit, and not just about the processing, not just about the cooling, but there are a lot, and I will not be going through all the other value proposition, all the other troubleshooting, all the other benefits that HPN Hyperform will bring. But these are just some of them, right? Warpage, sink marks, voids, pigment leveling, many more that it's commonly used in polypropylene injection molding. Moving on. So Deltamax is a very new to the world technology, which part of it also helps in terms of optimizing the processing condition of an injection molding process. But to take a step back, we are focusing here on impact copolymer polypropylene or block polymer polypropylene, right? For injection molding, it is always a case where the higher the MFR, the easier is your injection molding, less wider window, especially if your parts are large or your flow paths are very long. But there is always that balance or the tension, right? If you have very high flow ICPs, most of the time you cannot have higher impact ICPs. And if you need high impact performance, you are usually limited to the melt flow that you can have. And this is where Deltamax comes into play to target the space where can we have both high MFR and higher impact strength. To be honest, even right now, you can meet this with the solutions which is already available, for example, impact modifiers. But Deltamax is not just another impact modifier. It will manage your melt flow and impact strength at the same time without significant reduction of stiffness, which is the usual negative effect of putting too much impact modifier. And so this is a trial case, right? We work with a customer and we developed this Deltamax 80 MFR impact polymer, which has similar impact performance compared to a conventional 40 MFR ICPs. And we work with Modex 3D and we did some simulation. Of course, there's actual real mold trials, but this was a nice picture of, did some simulation where a 40 MFR control have to be injected at 230 degrees for this specific part that we choose. Of course, it's an instrument panel of automotive. But because of the higher MFR, at again, similar acceptable impact performance, we were able to reduce the injection temperature down to 200 degrees. And you can see there's no problem with filling, similar filling times. So if you have higher MFR, you have the opportunity to reduce the injection temperature. And therefore, all that we have talked about in the last few minutes is also relevant, right? Reduce the cooling time and therefore increase productivity. Therefore, this is a true example of crates And this particular example reduced injection molding temperature from 218 to 182 degrees Celsius. And because of the cooler melt, you can reduce your cooling time and therefore your cycle time from 57 to 46 seconds. And you enjoy again the energy savings, right? The kilowatt hour. So 36 degrees temperature, 12.5% energy reduction in cycle time. And for them, they had 58 days of added capacity or 110,000 additional parts that they can produce, right? Because increases
Hi, I think Mr. Samuel has his computer hanged. Dr. Fahmi?
Yes, assuming so.
Yeah, I think his computer hanged. So
So
yes,
maybe we
yes,
can proceed to the next presenter because
we
I think it's just a few, I mean, maybe one or two slides left.
yeah, two more. He has three more slides to go. So we
Three
will
more slides.
present. Okay, we'll move on to the next one. Over
All
to
right,
you.
right. Anyway, thank you, Mr. Samuel. I think this one I can share info with my students, okay? Because most of the time we only focus on the processing parameters or machine setup in order to reduce the cycle time, not the additive. All right, moving along to our session, please welcome Mr. Eric Chia. Mr. Eric Chia will be speaking to us on application of transparent ABS compared to other transparent resin. Please welcome.
Okay, thank you, Mr. Fahmi. So, good afternoon, everyone. So today, myself is Eric. So from Torre Plastic Malaysia. So mainly today, I want to present about application of the transparent ABS, which commonly known as the MABS, compared to the other transparent resin. So as the advancement of technology, so plastic has become an essential material to be used in our daily life. So on top of other plastic, so transparent plastic have become one of the common material that used for a lot of application. So for today, mainly my side will compare with the transparent ABS with other common transparent polymer. So before we start, let me introduce our company. So I come from Torre Plastic Malaysia. So we are located at Penang. And then our main business is on manufacturing of ABS resin. So transparent ABS are one of the grade that are produced by our company. And then mainly we are focusing on the polymerization and also on the compounding process. Then our capacity is about 425 ton per year. So we are certified by ISO 9000 and also 14,000. So our capital is about 948 millions per year. Oh, sorry. So this is some photo about our plant. So we are the first company to start on the manufacturing of the transparent ABS, and we are already accumulate about more than 40 years on this compound polymerization for the technology. So for introduction side, so people are chasing for the better lifestyle. So functional purpose had not become only the solely aspect to be considered during the product design. So visual or appearance also become part of the details that require during the design stage. So as you can see, like one of the example shown here. So this is the washing machine panel. So transparent polymer already become one of the choices that to be applied due to its the showing as like this photo here. So for the digital appearance, so this one as to show to the people that this value or even this kind of button also can be considered to be used for the ABS MBABS. Next, for the see-through effect, for the transparency, so transparent polymer also can be considered for the medical products such as like the syringe and like the container for the medicine. Uh, Beside that, we also can be considered for the beakers for our laboratory application. Next, so with the good mechanical properties, the transparency of the transparent plastic also can be aesthetic effect to attract the consumer. Like example in here for the monitor of our PC. So with the changes of the design time to time, so we can see that from previously all the parts is made by opaque materials. So we can see that there is some changes to the design, mainly to attract on the peoples for the aesthetic effect. So as you can see from here. And lastly, for this uh, transparent polymer, so we can offer a lighter or tougher alternative to the glasses. So this is for our introduction. So mainly today we will compare for the few common transparent polymer, which is the sun, GPPS, PC, PETG, and also on the PMMA. So before we start, I will introduce about what is transparent ABS. So for transparent ABS, actually is the polymerization between four polymers. So we start with the methyl methacrylate, acrylonitrile, butadiene, and also on the styrene. So each of these monomers will represent each their function. So example, so for the acrylonitrile, we are more to like chemical resistancy. Or another one is like styrene, more to the product rigidity. So many for the certain application is needed. So through the polymerization, by controlling like the rubber size or the matrix composition, so we can control our finished good properties such as like high flow, high impact grade or high rigidity grade. So from here, through a good compounding technology, so our material able to enhance to like special grade such as like scratch resistant. So for some application like high class home appliances or like audio application appliances. Even furthermore, through some additive, our material also can be enhanced to be like chemical resistant grade, which certain additive able to help our material to qualify for some medical device application. So how MABS to be transparent? So for generally, we know ABS resin is an opaque material where transparency means that the light are unable to transmit through our object. So ABS, we are grafting the PBD rubber, which is the butadiene, to the acrylonitrile styrene matrix. So due to the refractive index different between these two material, so the light is unable to pass through the object properly. So through polymerization between we introduce the MMA, which is the methyl methacrylate, into the AS resin matrix. So we able to alter the refractive index of our MAS resin. So we create uh, the refractive index similar to the PBD rubber. So to letting the light transmit through our plastic. So this is the uh, rough explanation for what I explained just now. So mainly this is the common material that light able to transmit through the plastic. And then due to the PBD rubber, the light is not passable to our resin. Next, by altering the AS matrix, so the light is able to pass through again. So we will start with the comparison of our plastic with other common transparent plastic. We will start with the sun. So the styrene acrylonitrile copolymer. So this is the general explanation. So for sun, which is the styrene acrylonitrile. So this plastic is our predecessor of ABS, which is rigid and amorphous plastic. So mainly that, like what I say just now, the polymerization between two different polymers. So we able to control the ratio between both monomers. So by altering the percentage of each monomer, we can create the require properties such example for acrylonitrile. If we further increase the percentage of this monomer, so we able to obtain a good chemical resistant grade. So mainly for this kind of increment of acrylonitrile is suitable for applications such as like this disposable lighter. So we need to resist some chemical degradation for these plastic parts. So for overall, uh, for sun, it is a excellent dimension stability and high rigidity and good chemical resistant grade. So one of the disadvantage for this plastic is it is quite brittle at the room temperature. So compared to MABS, sun is lack of rubber. So what I mean is the polybutadiene. So it will cause the parts to be lack flexibility, which crack is easier to happen during the application side. So this is the table comparison between sun and MABS. So in terms of performance, we can see that the MABS with the with rubber added, so the impact side MABS is slightly better compared to the sun. However, due to the rubber added into the sun, we can see that there is some drop on the heat resistance side and also the chemical resistance side. In terms of mold shrinkage, due to the ductility from the rubber, so the shrinkage will be slightly higher compared to the sun. And in terms of cost, also will slightly higher compared to the sun. But for these changes from sun, we know that the E&E product is quite suitable for this replacement and also for the stationary due to the snap fit design. So as you can see from here, this is for we recommend to change to this pen or mechanical pencil body and also for the cap side. As you can see from this photo, so this area which require frequent open and pushing parts that closing the cap. So higher with the assistance of the butadiene, which is the rubber, so the parts will be more flexible and cracking issue will be less to happen. Next will be like for E&E product application such as the remove control. So with the MABS to be used, so the IR light able to transmit through our plastic resin. So this will enhance the material to be used in this kind of application because of the toughness. During the assemble, the cracking issue also will be less to happen. And during our usage of this remove control, when this control fell down, so the cracking also will be less to happen compared if you're using the AS plastic. So next, we will move on to the general purpose polystyrene, so GPPS. So GPPS also is the main monomer is the polystyrene, which is the one of the monomer that used in the MABS. So for polystyrene is one of the most commodity thermoplastic resin that used in our daily application. So for this resin, for this monomer, so the main function is it is very high rigidity. So it is quite dimensionally stable, and then it have a very good flow properties. And then finally, it is quite cheap compared to other plastic. And then the disadvantage for this plastic is mainly similar to the sun, because lack of the butadiene or the rubber, so it's quite brittle in the room temperature, so it's quite prone to stress cracking. So as you can see, we will compare again for this material. So for the MAPS side, we can see that the impact will be slightly better compared to the GPBS. And then with the acrylonitrile exists in the MABS, we can say that the chemical resistance side is better compared to the GPBS. So in terms of better in GPBS is the cost is cheaper than MABS. So the recommended application for these changes is for like toy application. So as you can see in this photo, so there is some boss design, so which the screw maybe is needed for the assemble for the parts. So with the flexibility of the rubber, so MABS is giving more advantage over GPBS in this application due to the high resistance to crack. Other than that, for MABS also being an easy to wear amorphous material, so it can withstand a better mechanical force vibration and during the heat generated during the welding process. Okay, so we'll move on to the polycarbonate. So for polycarbonate is the one of the most widely used engineering thermoplastic in our current daily life. So it can be natural transparent due to the amorphous structure. So this is the structure that the PC have is the bisphenol A plus a carbonate. So it's quite commonly used to in applications such as luggage due to the high impact strength and high heat resistance. So the disadvantage for this PC is mainly due to some poor chemical resistance and susceptible to the hydrolysis. So as you can see for the chemical bond, so when there is moisture and high temperature for this in sorry, when high temperature and moisture is contained around the PC, so the ester bond will be easily break uh, and cause the structure to become bisphenol A. So for this hydrolysis, if happen, so mm, the MF the impact strength of this material will be slightly dropped before the hydrolysis happen. So this is one of the disadvantage when PC is applied. In terms of property side, we can say that the impact strength and heat resistance for the PC is quite good compared to MABS. Actually can say very excellent compared to MABS. However, for PC side, one of the highlight we found that is that the density of the NABS is lower than PC. So mainly this will be play a role which a part can be used lesser material compared to the PC. And then next on the chemical resistance side, MABS will be better than compared to the PC. And then in terms of processing temperature, so MABS is using a lower temperature compared to the PC side. So in other words, uh, by using a lower temperature also means that the energy saving compared to the PC grade. So for recommended application for this PC replacement, so one of the recommendation that we found we try is for the E&E product application for the robotic vacuum cleaner. So mainly for the display purpose and also for the infrared control to the remote control. And then next for like some toy application, so also similar to the complicated molded part and also for the light to transmit to the other parts. So the advantage is more to the easier molding due to the good flowability and the processability of MABS. And then for MABS also good for the secondary processing such as film coating, and it is cheaper compared to the PC side. So we'll move on to the PETG. So mainly PETG is commonly known as the polyethylene terephthalate, the PET plus glycol. So mainly this glycol added is to remove the hazing effect seen during the heating of the plastic. So mainly the PET with glycol is able to stop the crystallization of PET during at the high temperature, which make PET to be opaque and brittle. So one of the advantage of this PETG is very good chemical resistant to our common materials such as soap or other cosmetic material. So the disadvantage of this PETG is more to the high density and the difficulty for the molding process. So in terms of properties comparison, so for the MABS side, we can see that the transparency will be slightly poorer than PETG. However, and then for the chemical resistance side will be poorer. However, for the density side, similar to the PC, so MABS will be slightly lower compared to PETG. And then in terms of heat resistant, MABS will be slightly better. And then the compare in the processing temperature, the processing temperature will be lower than PETG. So this is some example of the product and houseware application. So such as like washing machine door screen, soap dispenser, and like water filter cover. So we will move on to our last application. So this is the PMMA. So PMMA is a most commercially important acrylic polymer due to its high transparency. So for this plastic, it only absorb very small amount of UV radiation, so it can have a very good weather resistant during the application side. So in terms of transparency, PMMA also show a very good optical clarity and a very high scratch resistancy. So similar to MABS, so this is a bit brittle compared in the room temperature. So this is some common application that we use for PMMA, such as like lamp housing or the shower cubicle. So for in terms of property, the performance wise, so we can see that the transparency of PMMA is better, and then the heat resistancy, scratch resistancy will be better than MABS. However, due to the uh, polybutadiene, so we can say that the choppy side, the impact side will be better, and it have a very better chemical resistancy compared to the PMMA, and then the price also will be cheaper than PMMA. So this is some recommendation for us to replace on the PMMA. So one of the molding technology is current exists in our market is the firm insert molding. So what is the advantage of this molding is that the flexibility of us to changing a model during the application side. So if you can see by using the firm insert molding, so we only need to change the design of this front PET firm, and then we can mold our MABS to the back of this PET firm. So for the manufacturer side, we'll have the more flexibility to change their design for the same for the more for the application for them, such as like washing machine or this air conditioner. So as the summary, this is the comparison between all the plastic that I showed just now. So mainly on the transparency side, the MABS is slightly poorer than other common plastic. But in terms of performance wise, it have the most balanced performance compared to other plastic. So in summary, for the current market trend, so external appearance had become one of the important aspect for the daily application. So for this transparent polymer will become a fundamental material to be chosen over the glass based on the cost and performance wise. Next, the good polymerization technology for these 4 different monomer, we can obtain a balanced properties among the common transparent plastic. And lastly, on top of household application, so MABS could be also a potential candidate for a specific medical application with the compliance of specific regulatory standard. That's all for me. Thank you. Okay.
Yeah, thank you, Mr. Eric, for very informative presentations. It is very thorough comparisons of MABS to other polymers. Okay, it looks that like we still have plenty of time. I would like to invite again Mr. Samuel to finish his presentations. Mr. Samuel.
Hey, hello, good afternoon. All right, sharing my screen. So apologies for that. Somebody asked me to change my laptop. I will blame the thunderstorm in Singapore. All right, I think I have like 4 slides left. To pick it back up, give me 5 minutes of your time. I was talking about Delta Max, where by increasing MFR while still maintaining impact strength, you can get some of the benefits optimizing the injection molding conditions. For example, here, right, reducing temperature, reducing energy consumption, and therefore reducing the cycle time because you are reducing the melt temperature and the cooling time. And depending on your capacity, you have more capacity, more days of capacity, and you can make more parts per year with your existing machinery, for example. And one of the area that we see that could be interesting is upgrading the recycled impact copolymer polypropylene. Delta Max is not only for recycled, but hey, recycled PP is still PP. If there is impact copolymer recycled in the stream, you can also use Delta Max to improve the recycle stream, because whether it's pre-consumer or post-consumer, recycle stream generally have more variability in MFR, more variability in impact strength. And if we can upgrade that, we can use it to easier processability of this variability in the incoming stream. And just some numbers here, where if we compare recycled PET, recycled HDPE, recycled PP, the percent reduction versus virgin resin production, right? Basically, any recycle usually is better than the virgin, right? So this is just some of the data, and we participate in the associations of plastic recyclers. And the challenge of using recycled is of the variability of the incoming stream, and things, specialty additives like Delta Max can help make it easier to use, and at the same time, like we explained previously, even optimize the processing of recycle itself. And that's it, right? Thanks for my additional 3-4 minutes, right? We have shared about the whole sustainability story, how we improve that in polymer processing. Let's not overlook the processing part. And here today, we introduce some of the additives, specialty additives, clarifying agent, nucleating agent, and also performance modifiers from Delta Max. That would really help to optimize any of PP users, and therefore energy consumption, improve productivity, and most important of all, enhance the sustainability benefits for our shared Earth. So thank you very much again. It was a pleasure to talk today.
Okay, thank you, Mr. Samuel. It is good that this time you are able to finish the presentation. Okay, now let's please welcome our last presenter, Mr. Nazri Muhammad from Ademixu Advanced Material Malaysia Sdn Bhd, with the topic World's First Syntactic Polystyrene SPS Resin, Zarek. Mr. Nazri, the floor is yours.
Okay, Assalamualaikum and a very good afternoon, everyone. So thank you very much at first for MPMA for this presentation. So today I would like to introduce to everyone about the world first synthetic polystyrene, which is we call it SPS resin, which is the trademark name is Zarek. Okay. Okay, guys, I have three items to be present today, which is a short introduction of Idemitsu, and also the introduction of our new project, as well as detail about the SPS Zarek. Okay, at first of a short introduction to everyone about Idemitsu. I think Idemitsu is quite well-known company in this world, as well as in Malaysia. So as you know, probably we are being in the history of petrochemical and oil and gas industry since almost 1911, which is the introduction, the establishment of the Idemitsu Shokai. So we have in history is about more than 100 years, whereby we also did the establish of the Idemitsu Kosan with various refinery plant in Japan mainly. So other than the oil business itself, we do have also the petrochemical, which been established in 1974, and also a few more historical, and the last is 2019. Idemitsu Kosan merged with Showa Shell Secure in April. Okay. So next, a bit introduction on the overall Idemitsu business. I think most of us know that Idemitsu is mainly producing a lubricant, whereby we can see everywhere the so-called Apollo logos and the red colors head in everywhere. But actually, for information, we do have a few more business in Japan as well as in overseas. Okay, so we do have as well the petroleum and petrochemical businesses, which is also the oil refining, sales, petrochemical manufacturing, and basis chemical. Resources business like crude oil exploration, coal mining, and functional material business as well. Electronic material, agriculture business, a lubricant, I think everyone know, and the advanced material as well. Renewable energy also we having a few more business in Japan. So for today, we would like to share with ladies and gentlemen about our functional business, whereby we have a recent expansion in Asia region to meet the demand of the globals. Okay. So next, a few more big introduction in Idemitsu in Malaysia. I think most of you know that we have 5 companies, include JV company with Petronas. We do have one JV company with PCE ethylene, which is polyethylene, whereby 12.5% is the JV from the Idemitsu. And at Pasir Gudang complex, we have mainly 4 companies, which is Idemitsu styrene monomer to produce styrene. And we have also PM, we call it Petrochemical Malaysia, which is producing the polystyrene. ICM, Idemitsu Chemical, which is the management companies, and also IAM, which is recently established on 2019. That will explain a few more about our projects. So a bit more, I think, but I will not explain in detail. We do have a JV company with Petronas, as well as an SRP, which is located at Vietnam. So we do receive the main monomers and raw material. And ISM will be, I could say, the heart of the Idemitsu company in Pasir Gudang, whereby ISM as well producing the styrene and to send for MS, for PM and SPS companies as a raw material. Okay. Okay, next we would like to introduce about our new project in Pasir Gudang. So as you can see here, actually our commercial operation will be started from Q1 2023 onwards. So we are located at Pasir Gudang, Johor. Later I will show a bit more details about the plant, where is it, and the plant itself we have about 300 square meters, and our capacity will be 900 metric ton per annum. So this is like I said earlier, this is one of the product in the world. Okay, and our mechanical completion tentatively set on September 22 next year. Okay. So this is our plant at the Idemisuk complex at Pasir Gudang. So you can see here we have 3 plants here, and our future coming plant will be located here. So others is our nearby companies, whereby this is the MSC area, and also we have a Sintomo also in the same Pasir Gudang complex. Okay, now this is the most important part where I would like to introduce our future products. Even though actually we do have our plant in Japan, so that's why this is the second plant, so-called producing by Idemisuk to meet the global market demand. Okay, so what is the SPS Zarek? This is a combination of the metallocene catalyst with the styrene monomer. Styrene monomer is our main raw material, where we do have a so-called metallocene catalyst, which giving a flexibility to structure of the crystallized polystyrene, which SPS. So through this, it can allowing the variety of benzene rings arrangement. So as you can see, this is our future to be SPS pellet, and it already producing in Japan for information since 1985. Okay. Short introduction. I think for the expert, I think they know what is the difference between PS and SPS, whereby we have mainly 3 categories of the PS. And the previous that we established at the existing plant in Pasir Gudang is we call it polystyrene, we call it conventional, and this is the SPS direct. So let we see the difference. So you can see the change of the polymer itself using we call it random or atactic, which is having a low heat stability. It is about 100 degrees. And also as compared to Zarek, as you can see the structure of the polymer itself. So we have a regular so-called, and so we call it syntactic structure. So this will allow heat stability for about 270 degrees C. And also a good chemical resistance and good electrical property, as well as steam and boiling water resistance. So this we hope we start to introduce or produce our first SPS from Malaysia start from 2023. Okay, so a bit more detail, more on the comparison related to conventional PS. So through the regular 3D crystalline structure, it can realize the engineering plastic range, whereby we have more advantage on this new engineering resin. So through the crystallization, it is actually one of our process. It can be additional characteristic, whereby I have been explained earlier, which is more better heat resistant, which is better chemical resistant, and also better dimensional stability, which I could say this is 3, a combination is quite excellent, which is giving a more value added for the SPS. So this is a comparison from PS and SPS, as you can see here. This is the main comparison, while for others, it is keep maintained as it is also SPS processes. Okay. So I would like to share with the audience is more detail on our Zarek features through our continuous R&D division lineup enhancement and high-end products. So we have a wide range of applications. So due to this main so-called the excellent properties of the SPS, which can contribute to lightweight resin, which is more preferable to use at automotive wiring terminal, which is not deformed by soldering, as well as reduced weight savings. So it also high insulating performance, whereby it can make a high voltage part for automobiles. So it stands for high electricity and high voltage, as well as it can be the highest insulation in all plastics. So other than that, it's also easily pass of radio wave, which can be used for inter-vehicle radar, as well as the smartphone where we have in our head now. Okay, so and in addition to that, due to this excellence for properties, it also having a high hot water resistance, which can be used for coffee servers, rice cooker, chopsticks, and so on. Okay. This is a big comparison comparing to PA, PBT, PPS, which is the group of the engineering plastic, whereby I believe each of engineering plastic having their own so-called advantage. It is based on the application that customer going to use. So as you can see in the blue colors, which is SPS, we have a big, I mean, more advantage comparing to others. Which is we can be allow us to use for various applications as I explained earlier. Okay. This is one of the big advantage of the so-called SPS. So whereby it has very low SG specific gravity, which is can give the advantages for the reduction of parts in a wake. Okay. And the second thing is heat resistant. Whereby, as you can see, our melting point will be around 270 degrees C, and also it moreover does not readily absorb the moisture. So this is one of the goods and a big advantage of the SPS. And a few more, but I will not explain in detail. It is also the chemical resistant, whereby it also high resistant to penetration for various type of acid, alkalis, and it also has excellent durability towards oil and antifreeze. So, and for hydrolysis resistant as well. So compared to with polyester-based resins and PA, so Zarek exhibit the superior hydrolysis resistant, and it boosts property close to PPS. Okay, and the last is dimension stability. Since it has small difference in mold shrinkage between flow direction of MD and TD, so it's exhibit a good dimensional performance. Okay. So this is more easily for audience to understand well what is our applications. So like I said earlier, since this is one of the heat and chemical resistant, as well as the lower specificity, which allow the light items. It can be used also for PCB connectors, which is mainly nowadays using in HEV, so electrical vehicles for the automotive application. So it have a various parts being used in our customers, like inter-vehicle radar in the car, so HEV motor terminal blocks, ECU housing, and so on. So this is an excellent balance of properties such as heat resistant, electrical property, chemical resistant, and more of a low specificity among others. Okay. And the second most application use is for home appliance and water contact application, whereby the Zarek is response for the increasing the advanced performance requirement for heat, water, electricity contact environment. So as you can see, this is a sample example which is being used for ovens, water dispenser, washing machine, and also for the rice cooker. So this is, I believe everyone have in your home, especially microwave. This is if you use this kind of rice cooker, and the so-called water dispenser, we have a lot of application to our customers. And also the main application for number 3, Zarek is possessed the excellent durability under harsh washing environments, employing the AC alkaline neutral detergent, which is mainly for use food containers application. So you can see it being used for many chopsticks, food containers, bento box, which is the transfer of food color can be avoided, and this container can thus be used over and over again. So, and the last application that we would like to share with the audience is the application for smartphone application. Okay, so the Zarek is suitable for high frequency components. It has stable electrical properties as well as a high radio wave transmission. So as you can see here, it's been used for smartphone for next generation. I think if you have some phone, you can see this line. And also this is actually having a purpose whereby it can allow the radio wave transmission for our smartphone. So due to this, the Zarek good advantage is their electric properties, which is close to those fluorescent resin in terms of low dissipation factors and also dielectric constants. So ladies and gentlemen, actually we have a lot of type of grade for SPS. So this is we simplify it, whereby we have made 4 series of the SPS type. So it's depend on the customer's need and application to choose each single grade. It's depend on the environment of the product itself. So whereby it apply the allowing and composite technology, which is having potential for engineering plastic, has been greatly expanded. So I think this is my last slide. So just to share with ladies and gentlemen that we have a big growth market demand growing well, which is estimated about 7 to 10% annually. So which is our compounding companies or customer as well is around in the world, in Europe, US, China, as well as in Japan. So with the big growth of the market demand, it can allow us, giving us a more confidence to expand our plant in Malaysia. Okay, and last and but not least, in summary, so due to Zyrite boasts a remarkable heat and chemical resistance, as well as a superior dimensional stability, it was preferred SPS in many fields, like I said earlier. And the second thing is Zyrite has been endorsed by automobile industry for use in critical electrical part and component, which have been collaborative effort with major end users. It is quite well-known company, if I say. Okay, but last but not least, number 3, Zyrite is often applied to lead-free reflow soldering to comply with the current environment, whereby we are environmental friendly products. So through this combination of 3 so-called advantage, this could make our first choice for many of our customers. Okay, I think that's all my presentation. Thank you very much.
Thank you, Mr. Nazri. This SPS topic actually remind me of polymer chemistry that I studied at USM 20 years ago. You know, polymerization, additive, catalyst, polymer backbone. Okay, in this case, I believe the wonderful work of catalyst that led to the discovery of new material. I mean SPS. Okay, now we will go ahead and take some time for a question. Quick question to Mr. Amos from Mr. Lai, and I think together with Mr. Wong. Any price difference between HE3490 LS and HE3490 ELS? And is HE3490 ELSH on PE 100 plus association list? Mr. Amos.
Hi,
Mr. Amos?
Amos.
Yeah, I'm here.
Yeah, okay.
Yes, there is a price difference between the LS and the ELSH. I don't have the detail, but if you need more information, I can refer you to my sales manager, who is able to provide you the pricing difference. And for the P100 association, P100 plus association listing, because this material is newly launched, and per P100 plus association, they need 2 test rounds to evaluate the material before they list it on the their website for this P100 listing. And this estimated will be end 2022, because we need to submit all the documentation of the test, and then they will kickstart the sampling and do the testing in their laboratory. Yeah. Okay.
So, I mean, it's also asking that 3490 ELSH, similar performance with LSH. So I think you are answering. And another question, does HE3490 LSH contain low sag properties?
Okay, this LSH, if you don't mind me reshare this particular slide. It shows here that for the required thickness, if you are running around this thickness, LSH could be used. It has intrinsic low sag performance, not because we design it this way. because first grade LS is a butene base, and LSH is a hexene base, and we designed this hexene base for high stress crack resistance feature. That means when you cut there's a groove on the pipe, the slow crack growth take a longer time, so to crack through the wall. Okay, and due to the hexene is a longer molecule chain, it has this increase in the time molecules within the cell, such that it provides this intrinsic low sag performance compared to the butene grade. But of course, ERSH is specially designed for low sag performance. With the same, we have this hexene also inside comonomer, but we have improvised this viscosity MFR to be on the lower end compared to LSH. LSH is the normal 0.25 MFR.
Yeah.
Hope I answered the question. Thank you.
I think it's very clear. Yeah, on the answer. Okay, thank you, Mr. Amos. This questions from Prakash to Mr. Samuel. Milad can be used only thin wall parts and only PP materials. I think Milad can be used only for this.
Yeah, got it. Yes. Milad is only used for clear polypropylene. But it is not restricted to thin wall, right? Any part thickness is possible, but yes, it is for clarification of polypropylene.
Okay. Okay, quick question. Another one, Delta Max. It's also on you, right? Okay.
Yes, I saw that.
Only applicable for PP or also the other polymers?
Unfortunately, yes. Unfortunately, it is also only applicable to polypropylene.
Okay. Okay. All right. Thank you, Mr. Samuel.
Thanks, sir.
All right, Mr. Eric. I think a few questions for Mr. Eric's. A couple of questions. Okay? The first question: one issue with MBAS we face with customer is discoloration. This is due to butadiene oxidation, correct?
Yes.
Are there any ways to reduce or solve this problem?
So for the discoloration, yes, mainly due to the oxidation of the butadiene. So what we recommend is that we can offer a higher UV resistant grade for this particular issue. And another recommendation is that you may use a lower AN content for this, maybe for your application. So I'm not sure, but you may try to use a lower AN content grade. Yeah.
Okay, maybe this question also related to the first question. Mr. Eric, we are having yellowish issue when using I think MABS on the finished good packaging parts, right after injection, even though with control process such as small temperature. Please advise.
So for this case, our recommendation is that you may select a lower rubber grade, because for MABS you may adjust of each monomer composition. So we can recommend you to try to select a lower rubber grade, or you may request to your maker to try improve on the antioxidant, mainly to reduce this oxidation issue. Yeah.
Okay, I think the similar question. Hello, regarding MBS, how to increase transparency during injection molding. So Mr. Eric, I've already answered. So next question, Mr. Eric, may I have indicative price of MABS? Thank you.
For this question, I will drop my email here. So maybe you can contact me. So I will forward your request to our sales PIC.
Okay. Okay.
So for indication price, for MABS is cheaper than PC and then slightly expensive than PMMA, roughly
Okay.
the price range.
I think it's good enough. All right. So another question: what is the highest temperature for MABS material can withstand?
Around 77 degrees Celsius. Yeah.
Sorry again, one more time.
77 degrees Celsius.
77 degrees.
Yeah.
Okay. All right. So the next question also the same. Currently using MABS PA758. Color seems to be a bit yellowish. I think it's the same issue with the first question, correct? Or you want to say?
So one of the question here mentioned is how to increase the transparency during the injection molding.
Yeah.
So there is some few recommendation, but you may try first to see any improvement or not. So one of the recommendation we recommend is on the increase of your molding temperature. However, you need to take care not to over increase, many to afraid later your mold parts become yellowish for the for the finished good. And then another recommendation is you try to reduce on your MTC temperature. Let's see any improvement after this setting change. Right. Thank you.
Okay, thank you. Thank you. Okay, this question, I think maybe last few questions for Mr. Nazri. Yeah, I think I go through all. Mr. Nazri, is SPS compatible with ABS?
Okay, I'm not really sure. This question is, I mean, it's related to mixing of between ABS and SPS. It's basically a different application. ABS is different application and SPS is different application. So in terms of compatible or not, I need to ask my research R&D team in Japan to get, and then I will get back to you this answer. Okay.
Okay, all right, okay. So next questions, how's the transparency performance of Xerac SPS and also price premium against PS?
Okay, about the price itself, I have to get back from exactly from my sales team, but what I know is the SPS is almost 4 times more expensive compared to PS. So if I'm not mistaken, the price is around, in Japan is sell about 500 to 600 Japanese yen. So it is about 20 to 25 ringgit Malaysian ringgit lah for that. Okay.
Okay, this is the question. I think it's a simple question. This is from me, since, like I say, it's remind me of my, university campus life. Actually, this SPS, what is the major changes, especially in the processing conditions, since the current SPS, when you compare the current SPS with the SPS that was first discovered, I think you mentioned it's 1985. Is that any big changes?
Okay, it's actually our secret recipe, but the difference is mainly a usage of the special catalyst with a combination of special catalyst. So it can create another or a new change of the, like I said earlier, the benzene, the structure will be more flexible. This is what I can say. I can answer for the question lah.
Okay. So you have been improved on maybe the catalyst type, and then as you mentioned that the combination of catalysts. Okay.
Yes, you are right. Yep.
Okay. So I think that last one, the rest is answer. Okay. So thank you again to all speakers for answering those questions, for great presentation. It was a pleasure to have you with us. So this concludes the webinar. Thank you. Thank you all for attending. I hope you have learned and enjoyed this presentation. And don't forget, the next session will be held, if I'm not mistaken, this Thursday at the same time, 2:30 p.m. There will be more interesting topic from PLASTECH Month 2021 webinar. That's all from me. Now back to Siu Ming. Please hold on. She has one important message for the audience.
Yes, we are.
Siu Ming.
Yes, thank you. Thank you very much. Please don't log off. We'll be launching a poll and we will take 1 minute. This is to improve our future webinar. It's also feedback for our MPMA PLASTECH Month so that we can improve. Please take 30 seconds to answer these 8 questions. We'll give it 30 seconds. Your feedback is highly appreciated so that we can improve for the further webinar and also for the following programs which we do online, which is what. So right now we have do answer. Can everyone see? Because we don't have any. Okay, we have 2. Okay, let's see 3. Okay, we give it to 1. Okay, let's reach around 60 out of 144. All right, more, another 10 more. All right, okay, we will end our poll. Okay, on behalf of MPMA, we would like to thank all the speakers. It was extremely insightful and very informative. And I think information is key to decision making. What you have shared is very highly appreciated. And from the look of the questions, we had quite a lot of questions that shows that there is a lot of feedback, or a lot of questions need to be answered. So what I'll do is if anyone has anything, please write on the chat group. We will direct them also to the speakers. So if there's any other questions. All right. And before we leave, I would like to have the speakers and the moderators, their video to be on, so we can take a group photos together with the MPMA Secretariat, the people behind the team, who has been spending a lot of time registering, because we have achieved 2,400 participants for the whole webinar. So yes, Mr. Eric. Yes. Okay, I will count to 3. We'll take 2, 3 photos. 1, 2, 3. 1, 2, 3. All right, Mouse. Okay.
Okay, before you leave, speakers, once again, our heartfelt appreciation. I think it's just not only from the Secretariat team, not from me, but on behalf of the organizing committee of the MPMA PLASTECH Month. Mr. Fahmi, Dr. Fahmi here is a member of that team. On behalf of the Central Committee members of the MPMA, please accept our sincere gratitude for all your effort, all your support. Thank you very much, and have a good day and good week ahead. And look forward to seeing all of you again. Bye.
Good job, guys.
Bye.
Bye. Bye.
Okay, thank you, everyone.
Thank you. Thank you, Encik Nazri. Thank you so much. Thank you, Fahmi. Thank you, Mr. Samuel. Good voice for the video. Thank you so much. Thank you, Mr. Amos. Thank you, Eric. Bye-bye.
Okay.
Bye. Bye.
See you again. Bye.
Bye-bye.
Bye-bye.
Okay, goodbye, everyone.
Hello, okay